Hello, and welcome to this video where we look at the concept of surface area. Surface area is going to be formed by rotating a curve, not a region, but just a curve in the XY plane about an axis. Let's say in this picture it is the x-axis. And we want to find out the area of the surface that is created from doing that. And the way we're going to do it, much like we found the formulas for volume and arc length, we're going to isolate one particular strip, find out what's going on there with the measurement, and then add up, at first, finitely many of those, but then let the number of those go to infinity. So, think of it as like a label. When you slice a label and unroll it, what you have is a rectangle, and you can find the area of that rectangle. Now, the area of the rectangle then will be the circumference. When you unroll it, that's one dimension, and then the height is the other dimension. And so the circumference formula is 2 pi times the radius. And so then we got to figure out what the radius is. And so what we're going to do there is basically take an average. We have the left endpoint of this particular band and the right endpoint, and we go and find out the y values there, okay? And then we take an average to say that what we have here is the average y. Let's call the symbol, let's use the symbol yi and yi minus 1, add them up and divide by 2. Now, when it comes to the height of the band, you can just connect the points. It's not exact. What we're doing is an approximation. There's the curve, which is going to be, what you use, but we approximate by doing a straight line, much like what we did for arc length. The distance between those 2 points. All right. When we derived the formula for arc length, we found out that there was a nice way to figure out how we can go from that straight line to the actual piece on the surface, and so the curve. And so what we have then is 1 plus the derivative squared with the square root over that whole term, those two terms, times delta x, the change in x. Okay. Well, when delta x is very small, basically, then what happens is the yi, the right hand height, and the left hand height, they're pretty much the same. The f of xi star, which is someplace in the middle where you find the height, they're basically the same. So you can replace the f of xi star with f of xi, and then the other guy, you can replace the y sub I minus 1 with f of xi star. So this f of xi star is not going to appear in the entire formula. Okay. Both underneath the radical and in the averaging part where we do the yi minus 1 plus the yi, those are basically both going to be f of xi stars. Add them up and divide by 2. When you have 2 of them, it just ends up as just f of xi star as your generic radius. Okay. All right, great. This is the area of this one particular band. And so we take a finite number, n of them, and add them up. It's an approximation. And the better approximation comes in letting the number of them go to infinity, or letting the width of the interval go to 0. This is a Riemann sum. This is the formula then that you can use to find surface area when you're in this situation. When you have the y equals f of x function between x equals a and x equals b, and when you are rotating around the x-axis. Okay, just to be clear. We might find ourselves in other situations, but here's a blow up of the picture. Maybe it's easier to see. So the ds is the curve, the piece of arc length, and the straight line there connecting those 2 points is an approximation to that curve. And so, with that said, then we can figure out that our job would be, what about if you rotate around the y-axis? What about if your function is given to you as a function of y? You know, most times we just deal with functions of x, but we definitely could deal with functions of y. And so, honestly, there's two deciding factors. There is which axis are you rotating about, and how is the function given to you? Or is it y is a function of x, or is it x is a function of y? Okay, based on these two deciding factors, you can figure out the formula for surface area. What we derived in the past two slides is just one of these four formulas that we're going to create. And so, when you have the axis of rotation, it's not going to be like when we had volume, where the axis could be something that's other than the x or the y axis. So with surface area, when we revolve for surface area, we're only going to use either the x-axis or the y-axis. So when it's time to answer this question, what is your axis of rotation? There's only two options. Okay. And when you have the y-axis as your axis of rotation, then the radius is the distance off the y-axis, and that's called x. When you have the x-axis as your rotation axis, like we had in the derivation, then the distance off the x-axis is y, and that's going to be your radius. All right, now, so the formula generically looks like that, and ds then can be either 1 plus y prime squared square root dx, or it could be 1 plus x prime squared square root dy. Depends on the variable. And that's where we make our next decision. You see, if the radius is x, though, and your integral is going to be in y, they're in disagreement with each other. If the radius is y, and your integral is going to be in x, they're in disagreement with each other. You can't have y's inside of an x integral. You can't have x's inside of a y integral. And so that's the heart of basically how you decide the formulas. Okay, which axis are you rotating about, and which variable are you going to use to integrate? Most times what happens is basically you'll be given a function, and then that's telling you which variable to integrate. If you're given x as a function of y, and a y range of values, then you should be integrating in y. If you're given y as a function of x and an x range of values, you should be integrating in x. Okay, so in what variable is the function given to you? And what range of values are you given? That tells you then which variable you should integrate with respect to. All right, so you're rotating around the y-axis where the radius is x. But you're going to integrate in y. You can't have this. You have to replace that radius with g of y. Now, if you're rotating around the y-axis where the radius is x, and you're going to integrate in x, then it's perfectly fine. You leave that x as the radius and don't do anything with it. That's the difference there. In one case, you want to replace it because you're in the wrong variable. In the other case, you want to leave it because you're in the right variable. Okay, move over to the x-axis rotation. The radius is y. If you do it in y, that's fine. They agree, so leave it. Don't do anything with it. Leave the y in there. But if you're going to integrate in x and your radius is y, they disagree, so you have to replace the y with f of x. This last formula was the one we actually derived. 2 pi f of x 1 plus y prime squared radical dx. Okay? All right, so that's the concept behind surface area. In the next videos, we'll do some examples. I just want you to know where the formula comes from, and know that there's actually multiple versions of the formula based on which axis are you rotating about and which variable are you integrating with respect to. When they agree, you leave it. When they disagree, you replace it. All right, thank you for watching. If you have any questions, don't be afraid to ask. I'm here to help. My name is Nakia, and yeah, like and subscribe. I'll see you in the next video. Thank you.